So, what is stochastic data? Stochastic means uncertain. It's from the Greek. For those who know what Monte Carlo is, by the way, Monte Carlo simulation, stochastic data can be thought of as canned Monte Carlo trials. And sometimes it can be exactly that, but there's also virtual stochastic data in which the storage requirements are just a tiny, tiny fraction of what would happen if you really did that. But we're now going to show how stochastic data on demand for that uncertain, the product we're trying to launch here, that uncertain data on demand is going to provide a better decision in terms of our capacity. Let's start with dice. I love dice. They're uncertain. The boss comes in and says, what numbers are going to show on the dice? That's ridiculous, isn't it? Give me a number, he says. And you say, well, on average, it's 3.5. So here we have an average die with 3.5 dots. Yeah, we've made a bunch of these. These are hilarious, right? Who would practice for their crap game in Las Vegas with average dice, for gosh sakes? Okay, so the way we get the stochastic data out of the dice is to roll them thousands of times. In this case, it's 10,000. And these arrays are known as stochastic information packets, or SIPs. So let's see how that works out. Here I have a model in native Excel, and about 10 years ago, Excel became powerful enough to process these SIPs with a function called the data table. You can learn more about it at our website. You can download this thing. It has no macros or add-ins in it. Oh, it's 3 SIPs, by the way, right? These are 10,000 each. When I point to a die and hit the enter key, it just rolled the first die 10,000 times. That was pretty quick, right? And we saw that we have an equal number of 1s, 2s, 3s, up to 6s. Not so complicated. Now, SIPs are like Lego blocks. When I add 2 dice together, I've played Monopoly before. I know there are more ways to get a 7 than a 2 or a 12, right? You can get a 6 and a 1, a 1 and a 6, a 5 and a 2, and so on. So let's see if it gets the right shape when we add 2 dice together. Here goes. Yeah, there are more 7s than anything else. Okay, that way they're like Lego blocks. When you put them together, they give you the right statistical properties. So let's multiply 2 dice. Yikes, look at that. What's happening is the outputs are all occurring on this data table sheet over here. It's live all the time, no macros. And let's look at some other statistical properties. So, for example, the average, when you multiply 2 dice together, it's just a native Excel statement. It says, take the average of that result array on the back page. And it also gives you chance-informed information. So the boss now comes in and says, I hear you're multiplying 2 dice together this afternoon. What number are you going to get? And you get to say, what number do you want, boss? I'll give you the chances. And the boss says, well, I want this number to be less than 6. And you say 27.6%, which is nothing more than a count-if statement. So stochastic data, to conceptualize it, arrays of outcomes, and count-if statements, and any other statistical formula you want.